All right, so let's kick things off. Welcome on behalf of Loyal VC. We are delighted to welcome Sébastien Raoux, one of our latest advisors. Sébastien has quite a gold pedigree in environmental topics, so we're delighted to have him speak to us today. I believe his PhD is in physics, which is actually what I studied many years ago, but he makes much more use of it than I do now. And he's among his other sort of claims to fame, he's one of the lead authors of the International Panel on Climate Change, IPCC. And he happens to live in Bariloche, Argentina, which is one of the most paradisiacal places on Earth, with mountains and lakes and forests and all the rest of it. And so we can all be slightly envious of him, but he's choosing to live in one of the most beautiful places in the world, which is probably why he thinks about how to keep the world beautiful. Let me turn things over to Sébastien. And Sébastien, we'll need you to unmute yourself.
Yes, indeed. You can hear me fine now?
Yes, thank you.
Yes, thank you very much, Kamal, and welcome all to this presentation. I'm going to talk about net zero startups. First, I will review what the science tells us about climate change. You've heard that the IPCC has released a major report late last year, is working on a second one now. So we'll review where we are at on that front. We'll talk about what is net zero. I'm sure many of you have heard about the expression, but what does it actually mean? And how do we achieve it? And it starts, like many things, by measuring where you are, and in this particular case, greenhouse gas emissions. So we'll see how we do that across the corporate value chain. And one of the key issues we'll cover today is we'll talk about why carbon offsets must be additional and why compensation is not enough. We'll talk, and I'm sure many of you are interested in that, about what are the investment opportunities created by net zero. And then we'll finish by talking about corporate climate governance, and especially for startups. So let's start with the climate science. This is taken from the latest IPCC report, the sixth assessment report. And we see now that climate changes are widespread, they're rapid, they're intensifying all over the world. You see on this map that some regions are more affected than others, particularly in the northern hemisphere, and we've seen that warming is stronger over land than over oceans, but it's strongest in the Arctic. And those changes are unprecedented in thousands of years. If you look at the CO2 atmospheric concentration here over 800,000 years, we see that since Industrial Revolution, the atmospheric concentration of CO2 is now 40% higher than it has ever been over the last 800,000 years. Those are actual measurements. This is actual data, and the same here. But in terms of temperature, you see that in the last 120 years or so, 140 years or so, the temperature follows the CO2 concentration, and we're now 1.1 degrees warmer than we were before the Industrial Revolution. So the Intergovernmental Panel on Climate Change, the IPCC, has now concluded that human influence on the climate is unequivocal. That means unambiguous, beyond doubt. This is very strong language, and I want to stress that the IPCC is an intergovernmental panel. Its members are governments, are countries of the world. This is not an NGO. The IPCC includes representatives from 195 countries, It's virtually any country in the world, and the IPCC operates by consensus. It means that there must be general agreement by all countries that the conclusions of the IPCC are supported by facts and by science. So the question is no longer about whether climate change is a reality. It is here. We see it in pretty much every country of the world. The question now is, can we slow the process quickly enough to mitigate the worst effects of climate change? And there is obviously a lot of uncertainty about this, because this concerns what will happen in the next 30, 50, or 100 years from now. And there is uncertainty because it's in the future, and also because it depends on what we will do or not do between now and the end of the century. But there is little doubt that if we continue on this path, we will see increasingly severe consequences and potentially abrupt and catastrophic changes if we pass some tipping points. So the issue is not whether climate change is real. The issue is, how can we limit its worst consequences? But the good news is that climate change can be slowed, and that the worst consequences can be avoided if we take action now. So, what is net zero? You've heard of it in recent months, particularly after the UN meeting in Glasgow in November. Lots of commitments on the part of many corporates to do net zero. Some countries pledging to go net zero. What does it mean exactly? Here on this curve, we're seeing the temperature, the global surface temperature relative to the pre-industrial time, and as I mentioned earlier, we are here. We've already reached plus 1.1 degrees, and the question is what's going to happen afterwards towards the end of the century. And I represented here. This is a curve from the IPCC. The expected temperature as a function of the CO2 emissions the scenario that we'll see. Currently, we're on this orange curve, the intermediate curve, and currently, if countries do what they said they would do as part of the Paris Agreement, we are expecting to reach 2.7 degrees by the end of the century. The Paris Agreement, which you probably remember, was signed in 2015 and entered into force very shortly afterwards, set two main goals. One is to maintain the temperature to well below 2 degrees C, above the pre-industrial levels, and pursuing efforts to limit the temperature to no more than 1.5 degrees C, which is this line that you see here. Again, we are already 1.1, so we're trying to stay well below 2 degrees, and if possible, not to exceed 1.5, recognizing that doing so would reduce the risks and impacts of climate change. To do this, as you see, if we want to stay below 1.5, we have to stay below that light blue curve, and if we want to stay below 2 degrees, we have to stay below that darker blue curve, which are represented by what is called the IPCC SSP, the Shared Socioeconomic Pathways. SSP1 in this case, the low is SSP 1-2.6 and very low SSP 1-1.9. There are many different scenarios that the IPCC has looked at to try to predict the consequences of climate change. The intermediate scenario is SSP2. SSP3 is very high, and SSP8 is very high. SSP8 is what is the scenario if we do nothing, right? We continue on that current path. So SSP1 is the one that will allow us to stay below 2 degrees and perhaps below 1.5. And basically the premise of this scenario is that the world will shift gradually, but purposively towards a more sustainable path, including more inclusive development, respecting environmental boundaries, improving educational and health investments, accelerating the democratic transition, shifting towards a model of economic growth that puts greater emphasis on human well-being and reducing inequalities, and shifting our consumption pattern to low material growth and lower resource and energy intensities. Those are fairly reasonable scenarios, I would say. There are things we should do anyway, in my opinion. But let's see how this translates into actual CO2 emissions. So that curve that we were looking at here on the upper left is in degrees Celsius. So let's take these scenarios and plot this against CO2 emissions, right? So this graph here on the lower part of the slide is in gigatons of CO2 per year, right? And again, we plotted these different scenarios: very high, high, intermediate, low, and very low. And you see that if we want to stay on that path of that blue curve here, that very low scenario, we have to reach net zero by around 2050. Means we got to lower our annual emissions from where we are today, about 40 gigatons CO2 per year, to zero by 2050. So net zero is this point where we reach an equilibrium where we would add no more greenhouse gases to the atmosphere than we could remove from it. That's, if we want to reach net zero by 2050 to limit global warming to 1.5 degrees, this is what we have to do. We have to reach that state, this equilibrium state, in 30 years from now. If we do it by around 2070, 20 years later, 25 years later, now we will not reach the 1.5 degrees and we'll get closer to the 2 degrees C limit. And of course, if we stay on that intermediate or high emission path, then we'll exceed the 2 degrees C target. So that is looking at the curve of CO2, but of course CO2 is not the only greenhouse gas. You have methane, you have N2O, you have fluorinated gases. So net CO2 zero is by 2050, and net greenhouse gas zero, including all the greenhouse gases, has to happen within 15 to 20 years after 2050. So around 2065, 2070. A delay of 15 or 20 years will means that we will not be able to maintain a temperature below 2 degrees. What does net zero imply? Let's take a look at just this blue curve, the very low, the light blue curve, the very low scenario, and see. Let's blow it up and see what it means in terms of CO2 emissions for the key sectors of the economy. If we want to reach net zero by 2050, it means that we have to fully decarbonize the power sector. It also means that we have to fully decarbonize emissions from buildings. In terms of mobility, we're not expecting that we will be able to fully eliminate emissions from cars and trucks and ships and planes, etc. But if we want to reach net zero, we have to reduce emissions by 60% for the mobility sector between now and 2050. And for industry, we have to reduce emissions by 80% between now and 50%. And then whatever we cannot eliminate by 2050, we have to compensate it by removing CO2 from the atmosphere, because of course this as I said, this is an equilibrium, right? We have to reach that equilibrium where we would add no more greenhouse gases than we could remove from it. So whatever we continue to emit, we'll have to find a way to remove it. And this can be done through what is called the NBS, nature-based solution. It can be planting trees, for example, or better managing agriculture, storing carbon in soil, and CCUS, the carbon capture, utilization, and storage, where we would capture carbon before it's emitted in the atmosphere, or even capture carbon from the atmosphere for that CO2 that's already there, and then reuse that carbon to make products or store it, for example, in the ground for long-term storage. This has profound implications, in particular for the energy industry and the energy supply, where we need to switch from a model that is dominated by coal and oil and natural gas, which represent 80% of our energy supply today, to a model that's dominated by renewables and low carbon energy supplies, solar, bioenergy, wind, hydro, ocean energy, and nuclear is also part of this. So basically, we need to switch from our current model where 80% of our energy is supplied by fossil fuel to one that will be supplied by renewables and low carbon energy at 80% level. So how do we achieve net zero? Well, first we need to measure, then we need to reduce, and then we need to offset. So what does it mean in terms of measuring? First, if you're a company, you need to, also if you are a country or a municipality, you need to develop an inventory, a greenhouse gas inventory. There are many different standards. I put the main one here that's relevant for corporations is the Greenhouse Gas Protocol. And the first thing you need to do is to set organizational boundaries. This is important if you have a complex corporate structure with many different corporations, subsidiaries, etc. The different ways to do this. But you need to also look at whether you are going to inventory your greenhouse gases across your value chain, or if you are going to do a product a greenhouse gas inventory. Those are two different methods. They are, of course, related, but they will tell you different things. You need to set operational boundaries, and basically that involves three scopes, and we'll go into a bit more details in the following slide. We typically talk about scope 1, scope 2, and scope 3 emissions. Scope 1 emissions, those are direct emissions from your own facilities, the emissions facilities you control, right? So it can be a fleet of cars if your company owns cars. It can be emissions from your factory if you have a factory, for example, that has boilers using natural gas or coal. Of course, when you burn this coal or gas, you will emit CO2. So those are your direct emissions, scope 1. Scope 2 emissions are indirect emissions in the sense that they are not produced by your company. They are produced outside of the facilities you control, but they are emissions related to your use of energy. So if you use electricity, and who doesn't, or if you use heat, if you use coal, you will have scope 2 emissions, right? You purchase electricity, but to produce that electricity, somebody, somewhere, a company, a plant has produced that electricity and may have released emissions in the process. This is scope 2. And then scope 3 is all the other indirect emissions that occur in a company's value chain. It can be upstream or downstream. We'll cover this in greater detail in the next slide. But you need to look at all these different sources of emissions and sinks, and then identify and calculate your emissions. Right. So that is not, the calculation part is not very complicated. Usually it just involves collecting activity data, multiplying that activity data by an emission factor, and it can be very simple. For example, if you own a fleet of cars, of course, you know how many kilometers each car has run during the year, and you multiply that kilometers by an emission factor that tells you how many grams of CO2 are emitted per kilometer. That's relatively simple. That's not where the complication is. The complication is when you have very large corporations with many different types of activities. So it's not in the multiplication that the problem is in the addition, in the correct addition of all the different sources that you have across the corporation. And then once you've identified in calculation and calculated your emissions, you need to track, verify, and report them. We'll talk about that in more details in a while. But before we go to the next step, let's see what it means to reach net zero emissions at the corporate level. The first is to achieve emission reductions that are consistent with the pathway to limit warming to 1.5 degrees. So you need to abate your emissions sufficiently that to meet the overall goal of 1.5 degrees. But that's the reduction part, but that's not the only thing. The second main aspect is that you will need to neutralize the impact of any source for which you cannot fully reduce your emissions, right? There are emissions, we do not expect that emissions will be avoidable in every case or every technology, but what we'll need to do is to neutralize the impact of those emissions that you cannot further reduce, and that's the offset part. So measure is the first step, reducing your own emissions is the second step, and then offset your emissions is the third step. But so to reduce emissions, second step, the first thing is to set a target, and there's this initiative. It's called the Science-Based Target Initiative that tells you how you can set a target that's credible and that will also be in line with the 1.5 degrees goal. And you need to set this target. You need to choose a base year. You need to choose a target year, and you need to put together a plan to reduce emissions within the value chain of the company. That is within the things you control. So to set this target, you cannot use offsets, and you cannot use what's called avoided emissions. It has to be truly abated emissions that you can abate from scope 1 or scope 2, your direct emissions or emissions from your energy consumptions that's required, and perhaps also from scope 3, which is required is if your scope 3 emissions are more than 40% of the overall emission. So that's the reducing emission aspect, the second step. The third step, before I go there, I want to mention, because many of you are involved with startups, which are smaller companies, the SBTi has a special treatment for a small, medium-sized enterprise. It's defined at less than 500 employees, if I'm not mistaken. And the process to set those targets is simpler than if you are a Nike or a Microsoft of the world. So then in terms of offsetting, it's important that we make the distinction between compensating versus neutralizing, okay? Because what most people do today is compensating. It's compensating is defined as a temporary balancing of companies' emissions with an equivalent amount of carbon credits that are generated outside of the value chain. of the company. So if you have a company, if you're a US company, and you say, well, I'm going to buy carbon credits from, say, Tanzania because they're planting trees over there, that's fine, but that's called compensating. It's not neutralizing. Neutralizing is removing carbon and storing it for long-term, preferably within the value chain of your company to maintain that state of net zero. Okay, compensating, buying carbon credits outside of the value chain is okay, but it's okay in a transition towards a state of net zero. It's not okay to do this forever. We'll see next in a couple slides why that is. Okay, here we're looking at these different scopes. We talked about scope 1, scope 2, scope 3. These graphs here, which you can find in the greenhouse gas protocol, explain what type of activities fall under what scope. So scope 1 is direct emissions, your company emissions from your company facilities, your company trucks, cars, etc. Scope 2, that's indirect. This is emissions from purchased electricity, steam, heating, and cooling. And then scope 3, you have upstream scope 3 activities, like emissions that comes from goods that you purchase, emissions from transportation, if you transport the goods and materials that you're going to use to produce your product. Business travel falls under scope 3, upstream scope 3. And then you have downstream scope 3, like what the emissions that are emitted during the life of your product. If you manufacture a car, obviously a lot of the emissions are going to come from using that car, driving that car. But if you are GM, those are not your emissions because you've sold that product. But those are calculated as scope 3, downstream scope 3 emissions. But there are also emissions that are tied to the end of life of the product, etc. So those are the different scopes of emissions. This is what you need to do to measure where you are at a particular moment in time. Then when you set your target, your roadmap for net zero, first thing is you need to know where you are. That's define your baseline year, right? Then you need to define your midterm target, and by midterm we say 2030, 2040. And what most people will is to abate their scope 2 emissions from their use of energy. And most companies start there because that's relatively easy to do. Instead of buying your electricity from a utility that is using coal plants, you buy solar-based electricity, wind-based electricity, renewable electricity. So that's where most people would start, and they abate emissions through renewable energy. Again, within the value chain, because this is not direct emissions; it's indirect emissions because you don't produce those emissions, but you use the energy. So you use the energy; it's within your value chain. Okay. Then most people will then try to abate scope 1 and scope 3 emissions. They're direct emissions, scope 1. So the goal here is to make the carbon footprint of your facility smaller. And people also look at abating scope 3 emissions, but again, within the value chain. If you do scope 3 emission reduction, it means you're talking to your suppliers. Say, supplier X, give me a product that has a reduced carbon footprint, please. And then in the meantime, and this can be done in parallel, most companies will compensate. They'll say, well, I cannot completely reduce my emissions yet, but I'm going to buy carbon credits outside the value chain to compensate, to be carbon neutral, and that's fine. This is great. We need that, but that cannot be the end goal. The end goal the long-term goal by 2040, 2050 is to neutralize your emissions, to reach that net zero state where you remove carbon from the atmosphere and reuse it or store it for long enough to fully neutralize the impact of greenhouse gas emissions that cannot be abated. This is the important part here. You will always, well, not always, but in many cases, we'll find that it's impossible to reduce emissions to zero. But the point is, for those emissions you cannot abate, you have to neutralize them. Okay. And this brings us to the point, and as I said, this is the most important question, or one of the most important issues here. This brings us to the point of discussing additionality. What does it mean? Why do offsets need to be a bit additional, and why compensation is not enough? The practice of offsetting is relatively simple, at least in theory. You reduce your emissions in one place to compensate for emissions elsewhere, and that's fine. You are emitting emissions from your factory in France, and you say, well, I cannot completely eliminate my emissions yet, therefore I am going to buy carbon credits from a reforestation project in Indonesia. So you pay for that credit. In exchange, the company organization that plants trees in Indonesia gives you a certificate that they have planted enough trees to reduce emissions by 1 ton of CO2. One credit is 1 ton of CO2. Okay. This is fine because by putting a price on carbon, this market, this voluntary emission trading, carbon trading market, encourage emitters to reduce emissions where it's most financially efficient. If it costs $50 per ton of CO2 for a company to reduce emissions by themselves in France, for example, well, they should rather buy a credit at $20 per ton from an NGO in Indonesia where it costs $2 per ton to plant trees. Okay, everybody wins. It makes complete sense and it's very, very efficient. This kind of flexible mechanisms, as they're called, or environmental markets are very efficient, are finding ways to reduce emissions at the lowest possible cost. But to be genuine, the carbon offsets must be additional. It must be additional to guarantee that emissions would not have been reduced in the absence of the project. Otherwise, this is what's called a hot air project. The point is you need to do something extra, right? You need to spend additional money to reduce emissions rather than relying on emissions that would have gone down anyway, right? Because if you don't do that, this would actually make things worse, because a company could continue emitting while pretending that the emissions are reduced somewhere else, but in fact continuing under a business as usual scenario, and this could lead to greenwashing, pure and simple. So the concept of additionality is essential. Let me take an example. 15 years ago, putting together a solar plant in a developing countries was nearly automatically additional. Why? Because back then, solar electricity was more expensive than, let's say, coal electricity, gas electricity, diesel electricity. So it's easy to justify, why would you do solar if it costs you more than generating electricity from diesel, right? And therefore, it was additional because you could argue that with the money from the carbon credits, then you are going to make solar electricity more competitive, and therefore there is a need for this carbon offsets, these carbon credits, to make the project event economically viable. But look, it's increasingly difficult to argue that solar projects are additional today. Why? because the price of solar electricity has gone down by a factor 10 in the meantime, and nowadays there are many places where it's actually cheaper to do renewable energy than fossil fuel based energy. So solar projects are now becoming harder to be classified, justified as additional. This would not be the case of carbon capture. If you want to do direct capture, capturing CO2 from the atmosphere today, it costs $600 per ton of CO2. So it's way expensive. So in this case, obviously it's additional because it's more expensive than not doing anything, and because it's and also in part because it's not been done before. So again, the point is, if you want to offset your emissions, those have to be additional credits that would not have happened, emission reductions that would not have happened in the absence of the project you finance. Preferably, those projects should also bring social and sustainable development benefits. There are many carbon credit standards that actually focus on this. And again, I want to make the point very clear that scaling up these carbon markets faster, with the caveat that they are designed correctly, is essential in reducing emissions in the midterm, okay? But compensating emissions can only be a near-term solution, because in the end, if the only thing you do is to compensate, we will not reduce emissions at the planetary level. If all we do is setting up projects somewhere to reduce emissions, to compensate for emissions somewhere else, and if this is the only thing we do around the planet, well, our emissions are going to be constant. They're not going to reduce, and we need to reduce them. That's why we cannot solely rely on offsetting emissions, on compensating emissions. We have to neutralize emissions. So first, we gotta reduce our own emissions. We have to abate. While we do this, we can compensate, but in the end, we will need to neutralize our emissions if we are to reach net zero. And besides, I mean, if all you do is buying carbon credits and not doing anything on your side to reduce your own emissions, this is not setting up the company to lead towards a decarbonized business model, or to mitigate the company's climate-related transition risks. So it's important that we first focus on abating our own emissions and using carbon offsets, carbon credits only in the near term. What can we do to offset emissions? I'm going to accelerate a little bit because I'm already at 40 minutes past, and I want to leave some time for questions. There are many different types of greenhouse gas mitigation interventions. You can do reforestation, afforestation, agriculture project, nature-based solutions. You can generate, transmit, store, use renewable energy, improve energy efficiency, reducing demand. This is a very important one. We can and we have to do this everywhere along the chain, in production, buildings, for cooling, for heating, for lighting, you name it. We got to be more efficient across the board. Increasing clean or climate neutral mobility, obviously, producing and switching to clean and efficient fuels, switching to the use of sustainably sourced materials. This is the hard one here. You know that every year by August now, we've already used all the resources that planet Earth can give us. We need more than 1.5 planets to survive over the long term, given everything we take from it. So solving this is going to be a very, very, very important challenge. Technology, innovation, industrial improvements will reduce emissions, and also switching to a circular economy, including preventing waste, reusing, recycling, etc. Those solutions are known. You're probably not learning anything here, but the point I want to make is that we have many of those offsetting solutions, technologies available today. Then the next big question is, are we investing enough towards net zero? McKinsey just came up with a report that says that we'll need about $275 trillion over the next 3 decades just for physical assets for energy and land use systems alone. So if you look at that in this scenario, this is a net zero by 2050 scenario, again from McKinsey. We'll spend about 2.7 trillion. We continue to spend 2.7 trillion on high emissions assets. They're not going to disappear completely. We are going to spend 2 trillion on low emissions assets and enabling infrastructure. We'll need to reallocate about $1 trillion from high to low emissions assets, and then we need to have more spending, $3.5 trillion spending in new spending on low emissions assets and enabling infrastructures. That's about that's what we're missing currently to reach this $9.2 trillion number that McKinsey has announced. So where is it going to come from? Well, let me make a suggestion. Is that we take this from some of the subsidies that we continue to put into fossil fuels. $5.9 trillion. We spent $5.9 trillion in 2020 on subsidizing the production and burning of coal, oil, and gas. So some of this is insanity. So we're shooting ourselves in the foot. Some of this has to go towards closing the gap, the financing gap for low emission technologies. Another source from the Boston Consulting Group has said that we will need as much as $21 trillion in new investments in low carbon technologies over the next 10 years. And they've released this study that shows that between 2016 and 2021, the private sector has invested about $157 billion in those low carbon technologies, principally in electric vehicle, 63 billion, energy storage, 36 billion, solar, wind, and nuclear. So that falls short, very short from what we need. So the answer to the question, are we investing enough towards net zero? The answer is clearly no. But perhaps more problematically, you can see like 90% of the overall investment went into only 5 technology sectors. So we'll need, and Boston Consulting Group says that we'll need 8 times the amount invested in 2021 to get the job done by 2030. I think this is an understatement. We'll need more than that. So let's say where we should put it, and as investors, I'm sure you're interested into where you could invest in towards the net zero revolution. Electric vehicles, we already saw that the majority of investment went into that sector. Things like, and we definitely need a lot of capital for putting charging stations. We need to develop a industrial ecosystem, electric cars. We need to move into electrified mass rapid transit, etc. So I took this key sectors, and then I looked at trying to quantify the priorities for investment in these different sectors. We'll see that there are many of them. Starting with the climate impact potential. So here the idea is to look at whether a particular technology can have an impact on climate change mitigation. I'm talking about midterm impact, like 2030. If you have a technology that has a longer term impact, it would get a lower scoring. Then looked at the paradigm shift potential, where technology can cause a profound change in everyday habits, processes, consumption patterns, or catalyze an impact beyond a one-off investment and result in medium-term to long-term change. The third criteria is to look at the CapEx investment needs. For the case of electric vehicles, obviously there are very large CapEx investment required, much more so than if you're trying to just do energy efficiency, for example, where you just replace light bulbs that are not capital incentive. So that's a factor in trying to prioritize those different sectors in terms of investment. And then one thing I looked also is the innovation potential, because for a startup in particular, the innovation aspect is really key. So I looked at all these different factors here. You see that for electric vehicles, I didn't put the innovation as very high. Actually, I consider that this is a medium innovative, because all the technologies are already there. I mean, certainly we need to scale them up, but that's not that's not an issue of lacking the technologies to do that. And I'm not saying that innovation is not part of electric vehicle industry. I mean, there are clearly things like autonomous driving, information technologies that are very innovative that will come our way. But if you look at the nexus of innovation and climate mitigation, I don't consider that autonomous driving is going to change or resolve the issue of climate change in the grand scheme of things. In energy storage, on the other hand, this is also a sector where there is very high impact, very high paradigm shift, because if we have better batteries, people will drive. This will enable people to drive without emitting emissions. They will and to do many other things that we do today with lowering emissions. It's also capital intensive, but there is a lot of opportunities for innovation, particularly to find longer lasting materials, longer lasting materials for longer lasting batteries. This kind of things. But innovation does not necessarily mean high tech. I mean, there is we also need to store energy for renewables, because they are intermittent. Right? The sun is not shining all the time. The wind is not blowing all the time. So the production of electricity from renewables, from many renewables, is intermittent. So because we cannot store electricity, we've got to efficiently. We have to produce it in real time. So at some point, it limits the ability to put more and more renewable energy into the grid. So we need to find an efficient storage. And there is, for example, gravitational storage. That's not high tech. This is there's a company called Gravity Vault that has invented a crane tower, that you have cranes that lift blocks of recycled concrete when there is electricity, when there is sun or wind, and lifts up those concrete in a tower. And when there is no sun at night, or when there is no wind, the crane will lower the blocks of concrete to regenerate electricity and re-inject it in the grid. That's not high tech, but that's brilliant. I wonder why we didn't have this idea before, because it's low tech, simple, low cost, and this is the kind of things that we really need. Then you'll see that I put the coming technology sectors. They all fall under other. We're clearly, there's so many opportunities, and we're clearly not investing enough in them. And I start with carbon offsets, because carbon offsets, this is a low-hanging fruit. We only invested $300 million in private investment between last year and 2016. That's a drop of water. We need to put more money in offset, and it is coming because with all those net zero targets and pledges that we've seen, a lot of people are now restarting to buy carbon credits. But the technologies there are mature. They are there. It's going to be easy to scale up, relatively easy to rescale up this market, because we've done it before. Maybe we can even say that we will resurrect the carbon offset market because it died nearly 10 years ago with the failure of properly renewing the Kyoto Protocol. Also from the other field, energy efficiency, that's another low-hanging fruit. Many of the technologies exist, they are there, they just need to be implemented. And usually energy efficiency projects have relatively decent returns. You reduce your electricity bill. So those are things that we really need to invest in. Agriculture is a very important and very innovative area where there are many things that we need to do, like using biotech to adapt crops to be more climate change resilient, mitigating methane emissions from ruminants, seaweed farming. There are lots and lots of things to do in the agriculture field. Then I put green hydrogen. Green hydrogen is really important. We'll need to invest very significantly into this, not for distributed energy, but green hydrogen, that is hydrogen produced from renewable energy, seems to be economically viable for bulk applications, bulk transport, not for distributed, not to put in your cars, but for bulk transport, like in ships, in trains, perhaps even in planes. And then also this is going to be key for industrial applications where it's going to be very difficult to decarbonize the processes, like in steel producing. The key with hydrogen, though, is that we've got to produce it cheaply. We've got to be able to pack it for transportation. And hydrogen is not very dense, so we got to solve that problem. It's probably not the best solution to just compress hydrogen and transport it. We'll have to chemically pack it and unpack it when at the point of use. I put bioenergy next, in particular algae, cultivating algae to produce biofuels, gasification processes. These kind of things are very important, with the caveat that it needs to be the right bioenergy project, because if it's not done correctly, you can impact the food supply chain and impact biodiversity as well. Then industrial productions. I mean, there are lots and lots of solutions out there, existing solutions that we need to invest in just to implement them. CCUS, carbon capture, use and storage. This is longer term, but that's also another of these other low carbon technologies that we need to invest in. Climate analytics is becoming very important. The ability to monitor climate change, assess disaster risk, map hazards, these kind of things. Lots of innovation possibly there. Fuel cells, waste to energy, ocean energy. And then finally, solar, wind, nuclear. I put it last, not because they are least important, but solar, wind, nuclear, they are fairly mature technologies. I don't think this is the greatest playing ground for startups. I think the startups are, there are many other technological areas where innovation is going to pay off much more significantly than nowadays in investing in solar, wind, and nuclear energy. So I don't know how much we need to spend in green hydrogen, how much we need to spend in agriculture for every of those technologies. Some will fail, some will some will be extremely successful. I don't have a crystal ball, but what I know is that we really need to scale up investments, and particularly on this other field that where there are many opportunities to invest, and we're not investing enough today. I was planning to talk about corporate climate governance, but I'm running out of time. So just let me mention a few things. It's important that the boards be accountable to potential shifts in the business landscape resulting from climate change. You need to assess your risk and opportunities and report and disclose. In the reporting and disclosure area, you need to be relevant, complete, consistent, transparent, accurate. The issue of integrity is, in my opinion, very important. You need to watch for claims of climate neutrality, green products, environmentally friendly. And you need to make sure that it's verifiable and that it's credible, or this could be perceived as greenwashing. And also this relates to this issue of additionality with respect to offsets, right? So the integrity of this climate compensation market is really key. So in conclusion, climate change is real. It's unprecedented. I think it's becoming very clear that we need to act now with resolve and ingenuity across all sectors globally. That reaching the goal of the Paris Agreement will require fundamental adjustments in economic and societal models, shifts in capital allocations, financial conventions for risks and returns, and will also require that we implement government strategies that integrate climate impact considerations in all aspects. Investments will need to be massive across all regions and sectors, but this will create growth opportunities, and many of those investments have positive returns as well. Innovation will be key in achieving net zero. In particular, technological innovation could hopefully will help reduce costs for net zero technologies, hopefully faster than expected. And this is where startups have a fundamental role to play. But remember, we don't have to invent everything. I hope I showed you that many of the technical solutions that we have already identified are out there. They already exist. It's a question of scaling them up. And this is where venture capital is critically needed. And then last point is, I think that net zero thinking has to become the new normal. We have to internalize the impact of climate change. We have to measure, reduce, and offset carbon emissions. We have to put a price on carbon, and this needs to become part of standard business practices. But I think the good news is that for startups, it's going to be a lot easier to design their net zero strategy, because it's a lot easier to do this from the ground up, from scratch, than if you have to redesign your entire supply chain like a Microsoft or an Amazon. And if you do this, I think this will give many startup companies a competitive advantage when shifts in demand, consumer demand, and behavior will drive people away from high emission products. So thank you very much for your attention. I took more time than I was planning, but I'm available for questions. Thank you very much for your attention.
And thank you very much, Sébastien, for a very interesting, informative talk. For those of you who need to run, it is 1 o'clock right now. Do feel free to run. We will stay on for a couple more minutes with questions. Just I'll confirm one thing with you, Sébastien. One of the questions from Osman, who's just jumping off there, is he said, if you had as an investor to pick one area to sort of focus investments on as both an entrepreneur or a venture investor, which one do you see the potential as? And if I understood your chart correctly, it looks like energy storage is perhaps one you would recommend. Is there another you would pick as well, or is it energy storage indeed the area you'd pick as the sort of most underfunded, biggest potential for innovation?
Yeah, well, this is the million-dollar question, right? Or perhaps even the billion-dollar question. But I don't think there is one in particular that will outperform others. I think, I mean, it should be evident that there are so many things to do across all sectors that it's really difficult to pick the one that will be the winner. But I think we'll have many winners in here. If I would pick one, if you ask me, I think that green hydrogen is really, really going to be key in solving the energy sector issues, particularly for sectors that are very difficult to decarbonize, where there is no solution that we can think of today. That's maybe in the longer term, it may take 10 years to get there, but I think this is a really, really important issue to solve. Energy storage obviously is very important, and you can see that from the chart here, where energy storage is second most important sector. But I wouldn't rather, I would rather pick something in the other category, because there's so many things. It's so underinvested that potential for growth will be higher in those more niche areas.
Perfect. And Michael was asking if hydrogen has a role to play in energy storage.
Well, you can store energy in the form of hydrogen. This actually it's a form of storage, because the idea here with green hydrogen is to produce hydrogen from electrolyzing water from renewable sources. So the idea is that you'll take a place where there's a lot of sun or a lot of wind, and from that sun or wind energy that you will harvest, you will produce hydrogen. So hydrogen itself is a form of storage. Okay, it's storage for renewable energy. Then the issue is the key issue will be how do you transport that hydrogen from the places where it's cheap to produce, in the desert, northern Africa, to places where it's consumed, like in Europe or in the US. And to do that, you need to pack it. You need to chemically pack it, and it's going to be a main challenge here. For example, you can pack it in the form of ammonia, NH3. So from H2, you make ammonia, which we know very well how to do. You transport the ammonia, which is a lot easier to transport than hydrogen. And then at the point of use, you unpack the hydrogen. So from ammonia, you make hydrogen again, and then you use it. So storage and or packing in this case, and the hydrogen, the green hydrogen economy are going to be interlinked. So it's an entire ecosystem that we need to build, with many of the elements from production to storage to utilization that need to be resolved.
Okay, perfect. Thank you very much, Sébastien. I think we'll wrap things up there. It's been an excellent session. Thank you. And thank you for allowing us to record it as well. And we will do feel free to follow up in future webinars. If you're one of our companies and you're interested in some advice specifically on your business from Sébastien, he is one of our advisors. So do feel free to reach out directly to him. Thanks very much, everyone, for joining us today.
Thank you very much, Kamal, for organizing this, and thank you all to your audience. Phil, do not hesitate to reach out if I can be of help.
See ya. Bye-bye, everyone.
Bye-bye.